Okay, so up to 8th, did you practice again? And the formulas that I had told you to do?
Yes, yes. Also, I had a doubt in the fourth one.
For this one.
Yeah, I could not solve that on my own. So you
Okay,
just show it to me once again later.
uh, okay, we'll start with that one only then.
Okay. School has taught us with only PPTs, so I did not understand anything over there. But I knew, that's why I knew till 7 and 8 also. They did it in a like a very short way.
What was that
They
method?
No, they actually divided. They actually, I don't know what they did because I did not write it like that. I wrote it like how we did it.
Okay,
That was, yeah, they did that cos theta. That is obviously the RHS is cos theta upon 1 minus sine theta. So they multiplied it by 1 plus sine theta, 1 minus sine theta. That way
okay.
only you have to do.
No, it is the same thing. Once you multiply,
Okay.
you said they multiplied it with 1 plus sine theta, correct?
Yeah, 1 plus sine theta upon 1 minus sine theta.
Oh, plus up and minus down.
So it must be minus up and plus
No,
down.
no, no.
Sorry.
It is not possible
They
to take different signs. They must have taken same signs up and down. So I think it would have been 1 plus sine theta upon 1 plus sine theta, both on the numerator and the denominator.
they just did they just multiplied it upon something upon. They did
Okay.
that.
Uh, you have a screenshot or something of that?
Um, I'll have to see.
Okay, no, it's okay. So you said they took the right hand side, cos theta upon 1 minus sine theta. And here in the numerator, they multiplied with 1 plus sine theta. Now in the numerator, if they did 1 plus sine theta, same thing has to be done in the denominator. 1 plus sine theta. Okay, so now if you multiply this, so this would become cos theta into 1 plus sine theta. And the denominator becomes of the form a minus b, a plus b. So it will be 1a square minus b square. Correct?
Yes.
So I doubt the answer will come. Okay, let's try. So this is cos theta. Cos theta is multiplied inside the bracket. So cos theta into 1 cos theta plus cos theta into sin theta will be, oh, I think no need to multiply inside the bracket. No need. We'll keep it as it is. Only denominator will change. We'll use the identity and change the denominator. Can you tell me what will happen in the denominator? So this will become 1 minus sine square theta. So what is it?
Sine square theta plus cos square theta equals to 1.
So 1
So by
minus,
rearranging, okay, will equal to cos theta.
yes, cos square theta.
Cos square.
Sine theta upon cos square theta. Okay,
So cos and cos you can cancel.
yes. So you will have 1 plus sine theta upon cos theta. And now you can, we'll get here. You can separate the denominator. So by separating the denominator, it becomes 1 upon cos theta plus sine theta upon cos theta. Now, what is 1 upon cos? You know this. 1 upon cos is reciprocal formula.
Sec theta.
Yes, sec theta. And sine upon cos is
Tan.
tan theta. So
So we
this
also did
is,
something like this only, right?
no, we started from the left hand side.
Oh, okay.
We started from the left-hand side.
So ours was shorter or
Yes,
theirs was shorter?
both are same, I guess. Both are equal. We started from this side and then we did cross multiplication and we got this side. So it is the
No,
same thing.
because our school loves to complicate sums, so that is why I thought they
No,
like to
what?
make sums bigger. All
Acha, the
our sums they solve it in the most longest way.
longest way. Okay. There are different methods to solve one particular sum. Different methods will be there. So it's not that some methods are wrong and some methods are right. All the methods are correct. Only just some method will be lengthy and some method will be shorter. Do you want to write this sum? Yes, it will be better if you write down this also. Can you see the entire sum? Okay, write it down. And then we'll do the fourth one again. Just don't get confused with the two different methods. We have solved the same sum. Okay, in the previous sum, we took the left-hand side and
I've
proved.
written question 8 then in a different way in the
Yes,
brackets and
yes, yes. So in that previous sum, we took the left-hand side and showed it equal to right-hand side. Here we have done the reverse. We have taken the right-hand side and shown it equal to the left-hand side.
I think this one is simpler.
Lengthy. No, this one is lengthy according to me.
Yeah, but the earlier one we had to do 1 ka square and then we
No,
had to
no.
eighth
In
sum,
the
right?
eighth one, yes.
Yeah, so eighth sum then later on we had to do right cos theta in the bracket 1 plus sine theta upon 1 square minus sine theta.
Yeah,
And
so here
then
also we
1
have done,
and
here also
1.
we have done same thing.
Yeah,
See,
yeah.
here also we have done same thing. So I think it both are same, both are almost same.
Yeah.
Only that here you will have to know that you have to multiply and divide by 1 plus sine theta. You will have to know that. While in that sum we are directly using formula and subtract doing cross multiplication. Only that one thing is different. Rest everything is the same.
Yes, done. We can do the fourth sum later on, I guess. Because the ninth sum and the 10th sum are two sums I did not understand at all. Four at
Okay.
least I understood a little.
Okay. Okay, so in the ninth sum, we have to show if tan theta plus 1 upon tan theta is equal to 2, then you have to show that tan square theta plus 1 upon tan square theta is also equal to 2. Okay, so this is given from this. Okay, from this, you have to prove this. Okay, from this tan theta plus 1 upon tan theta is equal to 2, you have to prove tan square theta plus 1 upon tan square theta is equal to 2. So you have to use this and bring
So
out
then you
this
just have
from
to
this.
square. Just square tan theta and square 1 upon.
But we cannot do term-wise square. That means separately each term square we cannot take. Like you cannot take tan square, first square the tan, then square this. You cannot do that way. If you're squaring, you'll have to square the entire expression. Each term you cannot square. So that's why the method is a little bit different. But you understood what has to be done? What is expected from this question? Did you
Yeah.
understand? Okay, so let's start.
Yes.
So we will have to use this and then prove this. So we'll write a solution. So write down this expression that is given to you. So tan theta plus 1 upon tan theta is equal to 2. This is given. Now, you have to bring squares. You have to bring squares for this tan. Here and here squares should come. So the only possible way of doing it is you square both sides. Okay, the only possible way
Can't
is
you not only square tan theta plus 1
no.
upon tan theta? Both of them together you cannot square.
Means you're saying like this for this square and then this
No. Tan, where written tan theta will come the first bracket and the second bracket add 1 upon tan theta square after that.
Yes, that only we are doing. Yes. So, but we have to do both
You
the
don't
side that
square 2. You
no.
only square that.
No. We will have to square 2 also, and the reason is because there is an equal to sign. So whatever you are doing on the left hand side, the same thing compulsorily you have to do on the right hand side because of this equal to sign. Is it clear why we have to do both the sides?
Yes.
Okay, it's just because of that equal to sign. You have to do both the sides. So let's see, tan theta plus 1 upon tan theta whole square is equal to 2 square. So both the sides we have done the square. Now, here we will have to use the formula. Now, do you remember the formula A plus B the whole bracket square?
A square plus 2ab plus b square.
Yes, so we will be using this formula on the left hand side. So this is A and this is B. Okay, now expand it using the formula. So A square, can you tell me? The expansion, can you tell me?
Tan theta square plus 2 tan theta into
B is
1
this
upon
one.
tan square, 1
No,
upon tan theta
yes,
plus 1 upon tan theta
square.
square equals to 2.
equals to 4. Okay.
4.
Now, just look at the middle term here, this one here. Can you see something is getting cancelled?
Tan and
Yes,
tan.
tan and tan is getting cancelled. Okay, so now this tan square theta, write it as it is. Here, just 2 is remaining, plus 1 upon tan the whole square will become 1 upon tan square theta, and this is equal to 4 as it is. Is it clear up to here?
Yes.
Now, can you see something happening in this? We can take this plus 2 on the other side. So what will happen when you take plus 2 on the other side?
-2.
Minus 2. So this tan square theta, write it as it is, plus 1 upon tan square theta as it is equal to 4 plus 2 went on the other side, minus 2. So what will happen on the right hand side? 4 minus 2?
2.
2. So haven't we finished the proof?
Yes.
Is equal to 2. So this we had to prove. This thing only we had to prove. Hence proved. Did you understand?
Yes, but I don't know how I'm going to remember all of this because there are so many sums and every sum you're using a different method.
Yes. Every sum you're using a different method, but the trend is the same. Such type of sums only are expected to come in the exam. Now, but such type of sum, they can change also a little bit. Like instead of tan, they can put cot and ask you to do the
But then
same
on
thing.
that side also they put cot only. Everything then will become cot only, right?
Yes. Here, this also will change. It's just that the pattern will remain the same, but they may change the ratio. They can put sign also. But you know how to solve it. Squaring
No.
both
Like
sides.
I was asking that here it is tan theta plus 1 upon tan theta. So if it becomes sine, then it will be sine theta plus 1 upon sine theta. Or it will
Yes.
become sine theta plus tan. No, right?
No. Both will be sine. Both will be sine. Here also,
Okay.
sine square theta plus 1 upon sine square theta. That way it will be. Okay. Now, this you will get by practice. The more you practice, the more you'll remember how much, what type of sum, which method you have to use to solve it. Okay, that will come by practice. Okay, can you see the sum?
Yes.
Okay, now understand each and every step and write. Okay, understand all the steps and write.
No, nothing. Yes.
Okay, so is that sum clear, the ninth one? I hope no doubts in that one.
Yes.
Okay, so let's move to the 10th sum now. The 10th sum, it just looks complicated, but it is not. So on the left-hand side, you have tan A upon 1 plus tan square A, the whole bracket square, plus cot A upon 1 plus cot square A, the whole bracket square. And that you have to prove equal to sin A into cos A. This we have to prove. So from here, we'll use the left-hand side and try to bring the right-hand side from it. Okay. Now, from here, first you tell me, do you remember the second identity? What is the second identity? Second identity
1
formula?
plus 6 square theta equals to tan square theta.
No, you said it the other way. It is 1 plus
Okay.
tan square theta is equal to sec square theta. Okay. 1 plus tan square theta is equal to sec square theta. Today, after the class, do you have another class immediately?
Not immediately, but in 15 minutes. 5:15.
That is the last class for the day, correct?
I have it from 6:30 to 7:30.
Okay. Then once all your classes are over today, you will write the 3 trigonometric identities. Okay. The 3 trigonometric identities, just the 3 formulas. First one, sin square theta plus cos square theta is equal to 1. Second one, 1 plus tan square theta is equal to sec square theta. And the third one, 1 plus cot square theta is equal to cosec square theta. These 3 formulas you will write 10 times each and send me the photos today itself. Okay?
Okay.
Okay, that's your homework for today. Okay, so now we will start with the LHS. So write the LHS here. Tan A upon 1 plus tan square A, the whole square, plus I'm just writing the question itself. Cot A upon 1 plus cot square A the whole square. Okay, so first identity is 1 plus tan square theta. Sorry, second identity is 1 plus tan square theta is equal to sec square theta. And third identity is 1 plus cot square theta is equal to cosec square theta. Okay, these are the two identities. Now what we'll do is, here if you see, this is the second identity, 1 plus tan square theta. And here in the denominator, 1 plus cot square theta is the third identity. So we'll just substitute the two values here and here. Is it clear what I'm going to do now? No? Yes.
Yes, I understand.
Okay, so we'll substitute. So this will be tan A upon, so this will become sec square A, and then the whole bracket square, you put it as it is. Plus, same thing here, cot A upon. This 1 plus cot square A will become cosec square A, and then the whole bracket square you put as it is. So is this step clear? Okay. Now, now here tan, you write it as sine upon cos. So this will become sine A upon cos A. And okay, wait, before that, what we'll do, we write this tan A as it is, tan A upon sec square A, the whole bracket square. What will this become? This square and this square together. Can you tell me? Sec square A, the whole bracket square. So when you take the square together, what will happen?
Sec 4A.
Yes, sec raised to 4A. Same thing you do here.
Cosec 4A.
A upon cosec 4A. Now, the next step you can skip if you can do it directly, but I will show you what the next step is. So next step, what you do is you write this numerator tan A into, now this sec raised to 4A is in the denominator, so that I can write it as 1 upon sec raised to 4A. Now this is just a method of writing. This is just a way of writing it. I'm just tan A upon sec raised to 4A, I'm just writing as tan A into 1 upon sec raised to 4A. Is this clear? Okay, same thing for the next one. So cot A into
1
1
upon
upon
cosec 4A.
cosec raised to 4A. Now the reciprocal formula, by using the reciprocal formula, what is 1 upon sec? 1 upon secant, which are reciprocals of each other, secant,
Cos.
cos. So 1 upon sec will become cos. But this is 1 upon sec raised to 4A. So
cos raised to 4A.
correct. Cos raised to 4A. Same thing this side.
Sine.
Yes. So this will become cot A into sine raised to 4.
But why did we change it into sine?
You look at the right side, what we have to prove.
Oh,
What we need,
okay.
sine A and cos A we need.
Understood.
Okay. Now, this tan here, I'll write it as sine upon cos. So this becomes sine A upon cos A. Okay, this tan I wrote it as sine upon cos into this cos raised to 4A as it is. Plus, what to write this cot as? Can you tell me what to write the cot as now? What is the formula for cot?
Cos cos A upon sin A.
Cos A upon sin A, and this into sin raised to 4A as it is. Okay. Now this side, in this side, what is getting cancelled? Can you see something getting cancelled off?
Cos.
Yes. So from here, this cos went away, and this from here one cos will go away, and you'll have cos cube A. Okay, cos raised to 3 or cos cube A. And here, what will get cancelled here? This side?
Sin. So it will
Yes.
become sin raised to 3A.
Yes. It will become sin cube A or sin raised to 3A. So we'll just rewrite it. So I'll get sin A into cos cube A plus cos A into sin cube A. Okay. Now, can you see we can take something common? What is common? What is common? This is one term here. This is one term. And this is one term. Can you see something common in both
So
the
you can get
terms?
sin A and sin 3A together and cos 3A and cos A together.
It is not cos 3. It is cos raised to 3. And sin
Cos
raised to
raised
3.
to 3.
Huh.
Yes.
Okay. So in this, from here and from here, one sign can be taken common outside, correct? And from here, one cos, and this cos can be taken common outside. So sin A and cos A is common. Is this clear?
Yes.
Are you sure? Or you want me to explain it in a different way?
No, is there anything further or is it over?
Yes, no. There is further, but did you understand why sin A and cos A is
Yeah, I
common?
understood this.
Okay. So what remained inside the bracket? I took sin A.
Yeah, sin square A and cos square A.
Correct. Sin square A and then the plus sign and cos square A. And by the first identity, what will this become? First identity formula?
1A.
1. No, not A, just 1. This one.
1.
It's just that instead of theta, we have A here. It's
Oh,
just
okay,
different.
okay. I
Just
thought it
different.
has a value.
No. Just different notation. Instead of theta, we have A. So that becomes 1. So sin A into cos A, and this is 1. And this multiplied by 1 will remain the same thing. So you'll get sin A into cos A, which is same as your RHS. So hence proved. Is this some clear?
Yes.
Now write down. Understand all the steps and write it down. Okay. Can you see it? Can you see it, or is it too small?
Oh, I can zoom.
Okay. I hope it is visible after zooming. Okay. Also, one thing, wherever the formulas are used, write down the formulas at the side, okay? Even if it is a reciprocal formula, write it at the side.
Can you zoom in? Because the question is, even though I have it in even though I have the textbook, yeah. No, because it looks like sign if you don't zoom. Yeah.
Okay, so when you're done this much part, tell me, I'll scroll up.
Yeah. Scroll down. Yes.
Okay, let's do the 11th one. Do you know how to do the 11th one? Can you try? Sec raised to 4a.
Sec theta will be 1 upon, oh, 1 sec. Yeah, sec can be 1 upon cos, sine can be 1 upon cosec, and tan can be sine upon cos.
Yes, and then?
So I'll have to do it till then I'll.
Yes. Yes, I'll give you one hint. This sine raised to 4a, can you see here? Sine raised to 4a. This you write it as sine square a raised to square. And then you may get the answer. Or else if you're not getting in that way, what you can do is you can try multiplying the sec raised to 4 inside the bracket first.
What?
Can you show me till now how you have started? Can you show it to me? Okay. One thing, I don't think that is helping. Writing sine square a, the whole square. I think this is not helping. So you write it as it is. Write it as sine raised to 4a only. Well, I can give you one hint. That 1 upon cos raised to 4,
Your
that
screen is
Screen is what?
Screen is gone. Now you stop screen sharing. Yeah, I can see it.
Okay, so you have written it like this, right? 1 upon cos raised to 4a, 1 minus sine raised to 4a minus 2. After this,
Sine
what you have written?
4a upon cos 4a.
Okay.
Wouldn't tan be wouldn't tan square a be sine square a upon cos square a?
Yes, but I'm seeing if that will help us in solving. It should help us also in solving. Otherwise, it's useless making it. You are saying this sine square a upon cos square a. Okay.
Yeah. Then we can bring cos sine and sine square cos square together somehow by interchanging their positions.
Also note one thing, I have to show that equal to 1. So all of this should give me 1. So that also you have to keep in mind. So let's see if it is coming like that.
Uh, can we do cos 4a and we can bring 2 sine square upon cos square a together and put 1 minus sine 4a on that side for some time.
No, we cannot do that because we are working just on one side. Na? You can multiply this inside, something like that can be done. We can multiply 1 upon cos raised to 4a. We can multiply it inside the bracket. That one thing can be done. I'm just seeing what else can be done. Wait, I'll just see whether we are getting the answer or not, then I'll explain.
Wait. Can you go
See?
up? You divided everything by cos 4a.
No, I did not divide. What I did is this 1 upon cos raised to 4a that was there, I just took it inside the bracket. Or else,
Then if you put it inside, then
don't change this. Keep this as sec raised to 4a. Keep it like this only. And then when I'll multiply sec raised to 4a inside. I'll explain to you. Let me see if the final answer is correct or not.
I'm not understanding what you just did.
Yes, I'll show you. Okay. To take the LHS. So our LHS, now pay attention, okay? Our LHS is sec raised to 4a into 1 minus sine raised to 4a into minus 2 tan square a. This is our LHS. From here, we have to bring 1, and that will be equal to our RHS. Now what you do is, first, now there is a different technique for this, okay? Some different technique is there. First, you write this sec raised to 4a as 1 upon cos raised to 4a. And this bracket as it is, 1 minus sine raised to 4a minus 2 tan square a. Is this step clear? Is this step clear?
Yes.
Okay. Now you multiply this 1 upon cos raised to 4a inside this bracket. Okay, so this into 1 and this into sine raised to 4a. So 1 upon cos raised to 4a into 1 will remain the same thing, minus 1 upon cos raised to 4a into sine raised to 4a will give you sine raised to 4a upon cos raised to 4a, and this minus 2 tan square a as it is.
Yes.
Is it fine up to here? Okay. Now what you'll do is this 1 upon cos raised to 4a, I know it is a reciprocal of sec. So again, I will write this as sec. So this I'll write it as sec square a. Okay, this became sec square a minus sine. What?
Why square? Sec
Oh,
4,
sorry.
right?
Yeah. Sec raised to 4a. Sec raised to 4a. And here sine upon cos will become tan. Since this is sine raised to 4a upon cos raised to 4a, this will become tan raised to 4a.
Raised to 4.
And this minus 2 tan square a as it is. Is it fine up to here?
Yes.
Okay. Now, this sec raised to 4a that is here. Okay, now this, I will write it as sec square a the whole square. Now, the reason I'm writing is because I want to use the identity formula here. The second identity formula I want to use here. And remaining thing, write it as it is. Okay, so now here in place of sec square a, use the identity. So sec square a is 1 plus tan square a the whole square minus tan raised to 4a minus 2 tan square a as it is. Up to here, is it clear?
Yeah.
Okay, now from here, next, I want you to solve on your own. Here, use a plus b the whole bracket square formula and expand it here. Once you do the expansion, some terms will get cancelled off. And finally, you will get your required answer. Will you able to continue do this for homework from here?
Yes, but till there I'll have to write.
Yes. Can you see it?
Yeah. What can I cancel?
After this step, after the last step, you're saying?
Yeah, because after this step I get 3 tan 4a plus tan 8a minus tan 4a minus tan square a.
After using the formula a plus b whole bracket square.
A, a square plus 2ab plus b square, right?
Yes. So how did you get 3 then?
Because 2 into 1 is 2 and 1 plus 2 is 3.
No, here a square is 1 plus 2ab. So a is 1, b square is tan square
Oh,
a.
so you don't take 1. I thought you...
It will
What?
be multiplication, not 2 into 1, it will become multiplication. 2 into a into b.
Yeah, so 2 into 1 is 2 and then 2 plus 1 will be 3, right?
No, why 2 plus? No, you cannot add it. No. You will have tan square a plus tan raised to 4a. Remaining two terms as it is. Tan raised to 4a minus 2 tan square a. Now minus plus 2 tan square a and minus 2 tan square a cancel. Plus tan raised to 4a minus tan raised to 4a cancel. And finally, you're left with only 1, which is equal to your RHS.
Wait. Can you do it again?
Which part?
You the step before you multiply a square plus 2ab. Just
This
explain
one.
that one. Yeah,
This
yeah.
one. Okay, so this is a square plus 2a into b. Now a is 1, b is tan square a. So that is why this becomes 2 tan square a plus b square. So b is tan square a. Now you take the square of this term, it will become tan raised to 4a. So the final is 1 plus 2 tan square a plus tan raised to 4a. Is it clear now?
Yeah, and then tan 4a and 2 tan square a, you're just taking like that only.
It's getting cancelled. This, na, yeah, that is as
Yeah.
it is. Yeah, this is as it is. And then
But how
plus,
did yeah, understood.
done?
Yes.
Okay, so we'll stop here. What is your homework for today?
I have to write the 3 trigonometric identities 10 times.
Okay, and send it today itself, the photo.